It's Mrs. Ratcliffe here, and today we're talking about the area of two kinds of shapes. So we're going to use what we know about the area of a rectangle and how you find it. And we're going to look at just two more shapes. One is the parallelogram, as you can see here. Now, parallelogram is just like it sounds. It's a shape where all the sides are parallel. And as you know, a parallel line is a line that continues and continues and will never meet. So you can see my parallelogram there. It's also a quadrilateral, which means it has four sides. Now, a parallelogram is really just like a rectangle that's gone a bit wonky or a bit sideways. And the thing about a parallelogram is you find the area very similarly to the way that you find it for a rectangle. The only big difference is we're doing base times height, but our height here means something different. So see how these blue lines are the sides of our parallelogram? See the red line? That's there to indicate height. Okay? See this little kind of, looks like it's a chair or like a little leg? That symbol right there? That's used in all of these kind of geometric problems to indicate a right angle. In other words, it's 90 degrees, which means that that line must be perpendicular to the base. So we know that that must be the line that indicates height. So this is our height line, and we can see that's 10 centimeters. It's shorter than this side of the parallelogram. Okay, so we're going to use the same formula though. Area is base times height. It's just that we find the height differently than we would in a rectangle. Our height is the length between the base and the top in a perpendicular way. So when we've got a 90-degree angle. Okay, so for this parallelogram, our base is 16 centimeters and our height is 10 centimeters. So the area is going to be 10 times 16, which is 160 centimeters. Okay, so it's not really that tricky. It's pretty straightforward. You just can't fall for using the length of the side in a parallelogram. Don't forget to look for the height. Okay, we're looking for this right angle. Okay, on a similar note, and something we've been practicing a bit all week, is the area of a triangle. The area of a triangle is figured out using this formula. Area equals half the height, and once again for height, we're looking for a perpendicular line directly from the base all the way to the top of the triangle. So it's not the length of the top sides, it's straight from the base all the way up to the pinnacle of the triangle. That is our height. Okay, so we want to calculate the area by taking half of that height and multiplying it by the base. So in this instance, you can see we've got 8 centimeters on this side, 7 centimeters on this side. Our base is 10 centimeters, so 10 for the base times half of the height, which here is 6 centimeters. So half of 6 is going to equal our area. So 10 times 3 equals our area, so it must be 30 centimeters squared. So this triangle is 30 centimeters squared in area. Now, I just want to explain why I've been having you cut rectangles into triangles and vice versa all week. It was to get your head around why this formula works, because I think that's really going to be why it's going to stick in your head, is if you understand why it works. So let me just show you that again, just to review what we've been doing all week. Why it works. So remember how when we had a rectangle, when we had a triangle, we were able to cut it up. We were cutting our triangles up the middle and then across the top, and then we were able to stick those sections down here and turn them into rectangles. Remember that? And then remember your homework we worked out was to turn a rectangle into a triangle. And we realized that if you drew a height that was twice the height of your rectangle and drew diagonal lines up to twice the height, these little chunks See these chunks right here? They can get cut out and moved over to here and fill that in. So these two chunks will get moved and put into there and there, and you would have a triangle with exactly the same area as your rectangle. So if you have a look at this triangle, this rectangle is 7 centimeters long by 2 centimeters high. So it's 14 square centimeters. So by cutting this chunk out and putting it up to this triangle, you would have a triangle that's also 14 square centimeters. Okay, so then we can extrapolate that that means half the height, which is 4, times the base, which is 7. That's the formula. So that's why that triangle formula works. I hope you understand that. Okay. All right, so let's do a couple of practice examples. The first one is a parallelogram. Now remember, for our parallelogram, we've got area is equal to the base. Our base is 5 times the height. Now look here, the length of the side is 4 centimeters, but the height is actually only 3 centimeters. See that? So we want the height. So base times height equals 15. And that's our area for our parallelogram. Okay, now let's look at our triangle. Just a reminder, for the triangle's area, it equals base times 1/2 the height. So our base is 9 centimeters, 9 times, not the length of this side, not the length of that side, no, our height, which is this red line here, from the bottom up to the pinnacle of the triangle, which is 4. So 9 times half of 4 is going to be our area. So 9 times 2 is our area, 18 centimeters squared. Okay, so I hope you feel pretty confident that you can tackle calculating the area of a couple of new shapes after this. Good luck, and keep practicing.